In this video, we are going to find the solution of second order ODE in Legendre's type equation. So the Legendre type linear differential equation, it is in the form of ax plus b the whole power n, d power n by dx power n into y, plus c1 ax plus b the whole power n minus 1, d n power n minus 1 by dx power n minus 1 into y, plus etc. plus cn into y equal to f of x, where c1, c2, etc. cn are constants. And it can be reduced to linear differential equation with constant coefficient by using the substitution ax plus b into capital D. Here d as d by dx. So ax plus b into capital D as e power z, that is z equal to log of ax plus b. Now consider ax plus b into d dy by dx as a theta, that is ax plus b into d equal to a theta, ax plus b the whole square d squared as a squared into theta minus 1 and so on. So now let us consider one example. Solve x plus 2 the whole square d squared by dx square minus x plus 2 into dy by dx plus y equal to 3x plus 4. So this is Legendre type. So this equation can also be rewritten as x plus 2 the whole squared into capital D squared minus x plus 2 into capital D plus 1 into y equal to 3x plus 4. So now we are going to transform this variable coefficient into a constant coefficient by taking x plus 2 as e power z, that is z equal to log x plus 2, and x equal to e power z minus 2, and x plus 2 into d equal to theta, x plus 2 the whole square d squared equal to theta into theta minus 1, that is theta squared minus theta. Here this is in the form of ax plus b, but a as 1, that is the coefficient of x is 1. So we directly take x plus 2 into d as just 1 into theta, that is theta. So as usual, theta equal to d by dz. So the equation 1 becomes theta squared minus theta plus 1 into y equal to 3 into e power z minus 2, that is 3x. So x is e power z minus 2 plus 4. That is theta squared minus 2 theta plus 1 into y equal to 3 e power z minus 6 plus 4. So minus 6 plus 4 as minus 2. So here also we are having two terms in the right hand side. So we get two particular integral pi1 and pi2. So our required solution is y equal to CF plus pi1 plus pi2. First let us find CF. So for finding complementary function, first let us find the auxiliary equation. Auxiliary equation is just to replace theta by m. So we get m squared minus 2m plus 1 equal to 0. This equation is m minus 1 the whole square equal to 0. So m equal to 1. So m equal to 1 is a repeated root, that is m1 equal to m2. So our complementary function is az plus b into e power mz. Therefore CF is az plus b into e power 1z. Next we are going to find the particular integral. So pi1 as well as pi2. So let us find pi1. So 1 by theta square minus 2 theta plus 1 into 3 e power z. So 3 e power z is case 1, type 1, e power ax. Directly replace theta by a. Here a is 1. So 1 minus 2 plus 1, 3 e power z. So we get 0 in the denominator. So in this case we put x in the numerator. So here we put z in the numerator, and differentiating the denominator we get 2 theta minus 2 into 3 e power z. Again substituting theta equal to 1, we get 2 minus 2. Once again we get 0 in the denominator. So this is not our required pi. So again we put z squared in the numerator, as well as differentiating this denominator we get 2 into 3 e power z. So in here we don't have any theta. So directly this is our particular integral 1. Next we are find particular integral 2. So 1 by theta square minus 2 theta plus 1 into minus 2. So here we are having only constant term. So we put e power 0 z into constant because e power 0 z value is 1. So this minus 2 will become minus 2 e power 0 z. So directly put theta equal to 0. So we get 0 minus 0 plus 1. So now our particular integral 2 as 1 by 1 into minus 2 e power 0 z. So e power 0 is 1. So we get directly minus 2. That take this as equation number 4. Now substituting equation 1, 2, 3, 4 in the solution set A, we get y equal to cf plus pi1 plus pi2. That is az plus b into e power z plus z squared by 2 into 3 e power z minus 2. So substituting z as log x plus 2, the solution will become y equal to a log x plus 2 plus b into e power log x plus 2 plus log x plus 2 the whole squared by 2 into 3 e power log x plus 2 minus 2. So this is our required solution for the given Legendre type linear equation.